Well, good morning. It's a pleasure to introduce Olivier Renault, the Eucalyptus geek, and he really is a geek, doing crazy stuff since 10 years and more. And I'll now hand the microphone over to his colleague Ron Recco, and he'll tell you a little bit more about Olivier.
Well, thank you very much. So yeah, we're here to show and talk and demonstrate Eucalyptus. It will be my task to do sort of the... Can you hear me okay in the back? It's up to me to do a bit of the boring stuff. Talk to you very briefly about who we are as a company, what we do. And then I'll introduce you to Olivier. And he'll do the more exciting stuff, showing our technology. First, give you some sort of an education of how the architecture is of our product, and then show you some really cool live stuff. And he promised me he will do both a UI-based demo and then a command line demo, because that's what real men do, right?
Yes, to be honest, Don wanted to just see the UI, and I've kind of managed to put some terminals there, so we'll have a terminal at some point.
Okay, thank you. If you can go to the next slide, please, Olivier. So this is the outline. I'll do the quick intro. So who is it? Eucalyptus. There are three things that we're very proud of. First, we've been around for quite a long time, at least in the space of infrastructure as a service management tools. We started as a research project in 2007, started a company in 2009, and from that point on until today, there's been way over 25,000 private clouds been deployed with our software. That also means that we have a lot of road-tested experience and a fairly large community. The other thing that is important for our company is that we were based on Amazon Web Services, the APIs of Amazon Web Services. It's always been our goal to be able to emulate the APIs. And since a couple of weeks, we've been recognized by Amazon Web Services because we never really asked them what they thought about that. But right now we know the answer is that they support it very much, and they picked us as their on-premise partner. So if you want to build a private cloud that is fully compatible with Amazon Web Services, our software is supported by Amazon Web Services to work both behind the firewall as well as in the public cloud from Amazon Web Services, which we think is really cool. And then, obviously we are an open source company. That's the other reason why we're here today. Okay, so because we have the same technologies, Amazon Web Services, the same APIs, what we can do is partner with a lot of companies in a number of different ways. I will not bore you with this chart, so let's move on to the next one. Here's a little slide that shows how we are compatible with Amazon Web Services. If you are familiar with Amazon Web Services and how they work, they have a number of different semantics and APIs. And this chart really shows with which type of semantics we are compatible. So for example, Amazon has a concept of an electric block storage. We call that cloud controller, and this is really depicted on the graph. So if you have developed something that works on Amazon Web Services, this is how it would work in the Eucalyptus Cloud. The difference, of course, between us and Amazon Web Services is that we run in a data center, so we run on physical infrastructure, we run on virtualization technology, and Olivier is going to talk a little bit more about that in the next few slides. So that leaves it to Olivier. Olivier is here today to present for us. This being Nuremberg and the SUSE headquarters, this is a very hostile environment for Olivier because, he worked at the other Linux software company. That's what they did, something like that. And he was responsible there in particular for the virtualization tool. And so he's really very fanatical about virtualization, KVM. He's also learned some of the other tools, and he's going to talk a bit more in depth about Eucalyptus. Olivier, it's up to you.
Thank you very much, Don. So, yes, I came from the ad company. We're doing mostly some ad stuff, but before I used to play with the lizard as well. So you know, I'm kind of okay. I know Yast and stuff like that. I've deployed quite a lot actually. Oops. Okay, so let's have a quick look at Eucalyptus. So as Don mentioned, Eucalyptus is IaaS solution. We are able to run a private cloud solution, and we try to mimic some of the part of the Amazon solution technology. So we install ourselves on premises mostly. We are virtualization agnostic, which means that we can work with multiple type of virtualization. My preferred one, KVM. I've kind of had that tattoo for the last 3 years at Red Hat. So yeah, KVM is the best, I promise. But we also support Zen, and we do also support another virtualization technology. I don't know if you've heard about Zen, VMware. You know, they're kind of popular nowadays, but you know, they've been here longer. That's probably why. So yeah, we support all three: Zen, KVM, and VMware. On top of this virtualization layer, we will then run some instances, and the way we interact with the instances is where we will mimic the Amazon solution. So it's exactly like on Amazon. We've got the EC2. The idea is basically you're going to define some instance type. So like on Amazon, you're going to say that you've got a small, a medium, a large, and you can decide how many of them you would like to have, and you define what the small is for you. So maybe in your environment, the small is going to be one single CPU with 512 meg of RAM and 5 gig of disk. And a really large one could be 8 CPU, 8 gig of RAM, and 50 gig of disk. That's what you want. That you define whatever you want. On top of that, we're going to have images. And an images is typically an operating system, and it can be an operating system plus an OS. And then the pretty part is that we assemble both. So you're going to define, for example, an OS which is Ubuntu, or RHEL, or SUSE, and you're going, or Windows. Actually, we support also the Windows families. And you're going to decide that you want to start an Ubuntu image with a small instances. And you're going to get one image, which is one CPU, 512 meg of RAM, 5 gig of disk, with this Ubuntu image. But if you want to try something a bit bigger on exactly the same image, you're going to start a large instances. And you will get exactly the same operating system. Obviously, the host name will have changed, the IP will have changed, otherwise it's kind of conflicting sometimes. I'm sure you've experienced that in your life. And you will have a bigger size. So you will be able to use exactly the same operating system on another image type. So that's the EC2 part. Then we can, we've got what we call we've got multiple networking modes. So the networking mode are can go from the most simple, where we will use your DHCP environment, and we will get the IP out of your DHCP environment, to the most advanced, where we will be able to isolate each customer's team, depending on what you would like to isolate, into a different VLAN. So you can define a certain VLAN, and this VLAN will be given to a team or a customer. And within this VLAN, in order to manage this networking and VLAN solution, we will ask you to provide us with a network segment. So you give Eucalyptus a network, and on the back of it, Eucalyptus will run a DHCP server effectively, and you will then have what we call the elastic IP. So you will have a private IP address which will be assigned to your VM, and you will have a public IP address which will also be assigned. And then one of the components in the Eucalyptus architecture will do some NAT routing, okay? So it will transfer from the public to the private IP address. Nothing magic, really. Then there is 3 types of storage within Eucalyptus. We've got S3-based storage, which we call Walrus. So our server, which is acting as our S3 storage, is called Walrus. And actually, if you can help us, we are just trying to define what is the plural of Walrus, because we would like to do a mega Walrus, and mega Walrus doesn't work apparently. So we want a plural of Walrus. So if someone's got the answer, Walrus being this big, fat animal which is on the beach. I mean, what's the right German name for it? Ah, it's walrus as well in German. Okay, great. So if you know the plural for walrus, we're interested. So this S3 storage is where you're going to store your instances. Okay, your images are going to be cut into chunks, and they will be put into the S3 storage. I will come back to the benefit of doing it in a bit. Then we've got EBS storage, so the elastic block storage, and that's where you're going to store your permanent data. I don't know, you probably all play with Amazon, and you've already all play with starting an instances on Amazon, and it's great, and you've done plenty of changes, and you switch off your instances because you want to do something else, and oh my God, where are my data? Where is it gone? So we mimic this behavior as well, where we destroy your data and we get them lost and everything. So Amazon had an issue for the data, and they created the CBS. So we do copy and paste basically. There's the mothership, and we're trying to do some Control-C, Control-V type scenario for the way of working. So EBS storage is where we're going to put our permanent data. And then the third type of storage, it's this ephemeral disk. So it's this idea that I start a 50 gig image, but my OS is really taking 2 gig. So I've got 48 gig of data, which I can play with and do whatever I want. I can write data on this 48 gig, but when I'm going to switch off this instance, or terminate the instance, the data which were on it, bye-bye, they're not here anymore. So it's kind of, I mean, I come from the infrastructure background where I want to have my data always permanent, and I use a SAN and fiber channel and blah, blah, and blah, blah. So it took me a while to get used to this idea of, and you mean that when I switch it off, there's nothing? Yeah, that's really, and it's not a bug. No, that's by design. So, okay, we mimic it by design as well. So then we've got obviously all of the identity management part. So you can manage user and let Eucalyptus manage user, but you may have already a directory in your organization, and we will be able to plug into this directory, being an LDAP directory or being a Microsoft Active Directory. Then we are, on top of that, we've got the IAM part which comes. So you can define which resources are being given to which team. So if you, for example, have some team which are defined in your Active Directory, you're going to be able to say, okay, this team is allocated, is allowed to use 10 CPU, 10 gig of RAM, and 500 gig of disk. And if they want to create 10 instances with 1 CPU and 1 gig of RAM, that's their call. If they want to create 2 instances with 5 CPU, which is kind of silly, but it's better for my 10 number, I can divide it better, and put 5 gig of RAM to each of it, that's also their call. So you allocate a certain number of resources, and then the team will be, or the group will be able to decide how they want to split these resources in their environment. Okay? All of the access to the instances which are being run are being done using a private public key mechanism. So you generate a key and you use this SSH key typically in order to log onto the Linux instance using the SSH, using SSH. Okay? We've got, for when you go into the VLAN, different VLAN, we've got VM network traffic isolation, meaning that each group is limited to a VLAN, and they won't be able to access the network traffic which is going by the other user on another VLAN. Okay? The good news is that you don't need to have any specific network equipment or any specific security equipment in order to use Eucalyptus, and you can just use it as is with normal solution. So there is few components which are making a Eucalyptus environment. So the first one is what we call the cloud controller. And the cloud controller is in charge of managing the access to the resources. So it's the one presenting the API, and is the one which is going to manage the user. Then next to the cloud controller, we've got the Walrus server. So they are at this level, yeah? So that's our Walrus server. And the Walrus server is where we store our S3 data into the environment. Then, for each cloud, we tend to have one cloud controller and one Walrus server. And then below that, we can have multiple clusters. So a cluster controller is where the party which is going to do the NATing translation, the network translation, sorry, and is going also to start the instances on the node controller. It's also called hypervisor, really. A cluster controller works with a friend called a storage controller, and the storage controller is IBS storage manager. Okay, so we can create a cluster depending on how many nodes we've got at the backend. So typically, we will try to do a cluster which don't go further than 100 hypervisor behind it. Or we can create different clusters based on location. You could have one cluster in your data center in Nuremberg, another cluster in your data center in Hamburg. Or you could also create a cluster based on the virtualization technology. So we are not going to be able to mix the virtualization technology as part of within the same cluster. So if you've got a cluster using KVM, every hypervisor in it will be using KVM. So we've just released Eucalyptus 3, or now it's what, 2 months ago we've released it? And in the Eucalyptus 2 world, that was exactly the environment you were getting. The downside of our Eucalyptus design is that if you were to lose one of, for example, the cloud controller, but you were really losing the access to your cloud. So maybe every instances were working, but you were not going to be able to access them, which was kind of, a bit of an issue, really. So Eucalyptus 3, one of the key components which is coming with it, is the high availability. So all components, being cloud controller, walrus server, cluster controller and storage controller, are able to work in HA. So if you lose one, in a good old HA fashion, it will be picked up by the next one. Okay? So it's an active-passive type cluster. It's not an active-active. It's always, so it's interesting because the cluster that they've implemented is actually active-active in the way that everything is replicated and synchronized at all time. But there is only one component being active at the same time. Okay, so let's have a quick look. Well, the high availability, we all know what it is. It's in order to prevent ourselves from failure. It's going to maintain service integrity, and it's also a good way of doing upgrade. You're not going to bring down your cluster, your cloud when you're doing the upgrade. You're just going to do a rolling upgrade. So you upgraded one component, and when you finish to upgrade the component, you move the service to the components that you've upgraded. So the cluster is monitoring, Eucalyptus is monitoring itself permanently in order to detect when a failure occurs, and when a failure occurs, being disk, being network, being OS failure, it will be picked up and the other one will take over. Obviously, if your both storage controller are going down at the same time, you're out of luck. But you can't prevent from double failure in a cluster environment. I mean, you can, but then when do you stop? So that's a typical Eucalyptus environment in a HA fashion. So we can lose any of the key component, and normally you may get a certain downtime in terms of whilst I move to the component to the other one. So there is a detection and then the pick it up from the other node. But we mean 10 seconds of unavailability, and then it's back online. Okay? So you won't lose any instances. What will happen is that you will lose some availability for a bit. One component that we don't have as highly available is the node controller, so the hypervisor. There is no availability on the hypervisor. The idea being, if you lose your instances, tough luck. No, it's not the idea. So if you lose your instances, you should be able to detect it by another mean, being your management solution, being your monitoring solution, being whatever you want. And when you lose an instances, you should be able to detect this failure and restart a new instances. So if it's the instance which crash because you've hit a bug in the kernel and you've got kernel panic, obviously it never happened with Linux. I mean, this is for the Windows side. But if it was to happen, you will be able to detect it and it will be restarted. The idea, of course, is that with Eucalyptus, you will probably work with an automation management configuration like a Puppet or a Chef in order to push back all of the changes onto your instances when a failure has just occurred. There is no such thing as live migration. We don't do live migration. I came from the virtualization world from Red Hat, so I came to my CTO and I said, and what about live migration? And he kind of said, no, that's not cloud. That's not the cloud way of working. The cloud way of working is if a failure, you start a new instances, you move the elastic IP to the new instances which is running, and that's the right way of working. And it kind of makes sense. But I've managed to convince him we needed live migration for some specific requirement, which is maintenance. When I want to do a maintenance of my hypervisor, I want to not have to go through all the old shebang of restarting, having a load balancer in front, and everything is nice and neat because I've got my load balancer protecting it. I would like to do some live migration sometime. And after a lot of convincing, few beers, we kind of agree to it. I hope it was not because he was drunk, but you know, I'm hopeful. Okay, so how does the image management part? So we spoke about the walrus stuff and the fact that I was creating little chunk, so I probably should have changed the logo to the lizard one this time, but you know, coming from Red Hat, I'm kind of a bit of a Fedora fan. So we've got multiple ways of creating images. We've got some open source tools which are really good for it. One of them is called AMI Creator. The other one is called Debootstrap. Debootstrap works nicely as well. There is a proprietary solution called UShareSoft, and that's going to create an image. Okay, so at the end, you will get an operating system with something in it. I'm then going to bundle this image and encrypt the image with the certificate of my user. So I can work as an admin and provide it to every user in my organization. Or if I'm a specific user and I want to bundle my own image and don't share it with anyone else in a proper open source fashion, I can do that as well. So I will encrypt the image with my SSL certificate, and it will then be stored onto my Walrus server, getting a unique identifier when I do it. Okay? So the names are not that easy. I can't say, and it's called Toto. We tend to use Toto a lot in France, but it doesn't work in German, I guess. It can't be called whatever. It's going to be a unique ID, and that's okay, but sometimes I will rather be able to call it Toto. So what's happening when I'm now starting an image? My hypervisor, which is represented somewhere. No, it's not there. So yeah, so I've got the different instances types that I've defined. So there is one which say 1 CPU, 256 meg of RAM, and 3 gig HDD, up to a large, which I've defined as 4 CPU, 8 gig of RAM, 30 gig HDD. So I'm now a user, and I'm saying, start this instance, start this image. I really haven't put the SUSE logo anywhere. Start the Ubuntu image and my large one, and it's going to assemble itself and go to the hypervisor. So my hypervisor is actually going to go and download it. Do I've got it here? Yes, I do actually. So yeah, so I'm a user. I'm saying I'm connected to my cloud controller to speak to my cloud controller, and I'm saying, okay, let's start an instance now. So the cloud controller go to the cluster controller, and the cluster controller go to an hypervisor. The hypervisor requests it out of the Walrus server, and yeah, the benefit of storing it in S3 is that we don't need to have a SAN connection or share storage to all of my hypervisor. All of my hypervisor are using their local disk, so there is no need to have an expensive SAN array at the back end in order to work with Eucalyptus. You can just work with your normal local disk and a bit of storage on the Walrus server. So I've now started my instances from, I've now downloaded the different buckets onto my node controller. I've rebundled my image, and I'm now starting my image. Then after that, I can have my user connecting to the cluster controller, and it's going to do the NAT trafficking to go to the public IP address that I've assigned to it. Okay? So my node controller is totally out of the picture. It's even on another VLAN, another network. No one sees it. And the cluster controller got a public IP address that is communicated to the user, and it's the user which is able to use it from here. Okay, so we're mimicking also the security group part of Eucalyptus. So by default, when I start an instance, nothing is reachable. When I create a new security group, I say start an instance in it, there is no port which is open by default. So you can try to SSH, doesn't work. So you need to specifically open the port that you want to get access to in order to access your instance. So the firewall is done at the cluster level, let's say, and not at the instance level. You can obviously do one at the instance if you fancy as well, but that's not required. An instance in security group A is not able to speak to the instance in security group B. You can effectively open some port and say security group B is able to speak to security group A, and that's okay. So what we tend to see is that when you do a 3-tier architecture, or 2-tier architecture, let's say, you're going to have your web front end with maybe port 80 open, and then you're going to open, and you're only going to present to the outside world the port 80 from your web front end. Then the database server will be behind the security group, behind the web front end group, if you want, and it will be only from the web front end that you will be able to access the images, the database server, which are in the other group. Okay? So you can really restrict which access you give to your VM. That's what I was saying earlier. We can have different VLAN isolation. So if you've got multiple users, you can say that user A is going to work in VLAN A, user B in VLAN B, and user C in VLAN C. They can be across multiple node controller or multiple clusters as well. And that's another view of what I was saying earlier. You've got your web server, and the ports which are open for your web server are 80 and 443, and only the web server can access to the DB server and to the app server, and only the app server can speak to the DB server. So it's role-based firewalling, and they can speak through that. In order to access to the AWS, so the solution is you can build it as an hybrid solution, so you can burst onto Amazon when need be. We can use the VPC solution from AWS to do it. For the load balancing part, currently we don't have the elastic load balancer, so we rely on the good old HA proxy configured in a load balancing fashion, or an Nginx, and there is a document which explains how to configure an instance to do that on Eucalyptus. Okay, do you have any question? So, okay. So I'm just going to quickly show, if I find where it is. No, that's not the one. That's my puppy. And now I just need to find my mouse. There we go, the mouse is here. So from a web front-end, so we having multiple partners which are providing different web front-end. This is one which is called on Stratus. We support on Stratus, we support Riscale, we support Scalarium, we support AWS Manager. There is plenty of solutions which are available in order to work with Eucalyptus. So this one is bundled by default with the Eucalyptus product. So that's why I've chosen to show this one. So that's the different images that you're allowed to work with. So you've got an Ubuntu, you've got a Windows, you've got CentOS, you've got some RHEL, and they are either given to no one in particular, meaning everyone is able to use it, or they are being defined to a specific group of users, or they could even be defined to a specific user. So only this user will be able to use them. There I'm logged as an admin, or otherwise called root, and that's why I've got access. I can see everything, basically. Okay? So I can pick up, for example, that one. And if my mouse wants to reply. Okay. I may have an idea what's wrong. Sorry. What, to lose a network connection never happened on Windows? No. Amazing. So bear with me 2 seconds. Just need to find again my mouse. So, sorry, I'm just connecting to my environment using SSH, and I seem to have a drop on the connection. So, if you bear with me, I'm just going to restart the connection, and we should be back online. Do you have lot of experience with AWS at the moment? With Amazon Web Services? Are you all using Amazon Web Services or not at all? You're currently using virtualization, I take it, because everyone does nowadays, so I'm sure you also do. Which one do you use? Have you gone for the most popular one, or a bit more adventurous by using something a bit more open source way?
All of them.
All of them? Good answer.
Okay.
Hey, yeah. Here we go. So, you see it happen on Windows as well. That was the Windows stuff that I'm logging on. So, here we go. The mouse is better. There we've got stuff. So, I've got an image. It's here. I can now choose to start it. And sorry, the screen is a bit small. There it's a launch, really. Trust me. It's going to spin. Okay. So, I'm going to be able to give it a name. So, my preferred name, Toto. I give it a description, something quite clear and meaningful. I can decide in which budget code is going to be assigned to. So you can, each team can be assigned to a budget, and they will be able to start instances based against the budget code that's being defined. So I'm going to put in the default budget code, because like that's not me paying for it, which is better. I can choose what sort of image I want to have. So being small, high, medium, large, blah, blah, blah. So I'm going to go for a small because I don't want to cost too much. And that's the security group, otherwise called firewall. Okay, so I've got a firewall which is default. It let me speak to port 22. It's a Linux one, it's going to be plenty. I can define if I want to terminate the instances after a certain amount of time. Okay, so it could be up to a month. Well, we're going to say 30 minutes, like that. I won't have to do it afterward manually. And I can put the nice color in order to green for the lizard. And then which SSH key do I want to use? I've got an issue with power, so I want to be root ready. So there we go. And then when I've done all of that, I'm saying launch server. And what's going to happen in the backend is that it's going to go to my Walrus server, like we've seen. It's going to download all of the bucket, go onto an hypervisor which got some free space, and it will start these images on this hypervisor. After a while, what should happen is that this image should be seen should be seen here, and I will have a server which should be in a pending state. So the bad news is if I don't see any. Hey, I've got one called Toto. That's probably the one. Is in the pending state. Okay. The public IP address that I'm going to use to connect to this instance is that one. Okay. All good. Everything's working as designed. So we're going to give it a bit of time. In the meantime, what can I do there? In the meantime, we've got images, we've got instances, but really sometimes I don't want to just start an image. I want to do something a bit more complex than just starting an image, and I want to start an application. And an application could be made of multiple images. Okay? So that's what we're going to look at. There we go. So I've got, for example, one there where I've got a Tomcat server, a load balancer. Okay? I've got a Tomcat server there, and I've got the database running Postgre. Okay, so it's made of 3 different images, and I'm going to be able to decide how those images are going to be managed. So I can go there, and if I scroll down, so I can give it a color. It's always nice to have a color. But most interestingly, I can say, okay, I want to have 1 to maximum 10 servers. I'm going to start them automatically based on some rules. So the rule could be really simple, typically CPU, RAM. I can say when I'm going to start a new instance when the threshold on CPU is going to be above 75% for a period of 5 minutes. So, okay, CPU RAM is good, but sometimes, it's not really interesting to monitor CPU and RAM, and you're better monitoring something a bit more relevant to your application. And I can also do that. So I've got what we call custom rules, and in the custom rules, you define whatever you want. If you're able to write a script, and you can get a return code at the end of it, we will pick it up, and we'll be able to work with that, which is pretty cool. So I can do that for my web server, or my Tomcat servers in this extent, but I can also do that for my database server. It's going to be slightly more complex with database, because database, to get the scalability, it's not as linear as just adding some new server on the side. So, but I can also do that. There, I've got another part which is interesting, which is, oh, wrong button. I've got, what we're looking at there is a single data center, okay? But I can just add a region here, and then now I've got my other data center. And I can decide where I want to start my instances, in which data center I want to start them, and what are going to be the rules for me to start instances in which data center. Okay? So I could have DC1 running instances and DC2 running always 1 or 2 instances. Based on the timing of the day, because my data center are located in Europe and one in the US and one in Japan, and my users are going to bed at some point, and I should have done that last night, really. You are able to start your instances in the different region based on the time of the day, typically. So that's from the admin perspective. From a user perspective, I can just produce a nice, neat catalog and show. Okay, you always have this demo feeling when something doesn't reply very quickly. So I've got a nice email. And so I show a catalog, and my user can come and select out of this catalog what they want to see. Every tab that you see at the top can be shown or displayed based on the rules and based on the permission that you given to your user. Okay? So there is a nice role-based access which is behind it. And if I look into user, I can define roles. Roles, here we go. So I've got a role which is called developer. And if I look at the access right, my developer can do, not much really. He's able to start, stop instances. Is able to start and to terminate some server, and that's, I don't know, is able to also start and stop deployment. So if I log with my developer account, I will only show that, I will only display that, okay? So it will be basically presented with a portal, which what do you want to do? Start this instance, start an instance of this type, or start a deployment of this type. So it's a really nice way of just showing of just providing a standardized environment to different teams in your organization. Okay, so that was the web user interface part. Now we've got something else. Okay, but still web. So I've got an Hadoop cluster. Okay, so I've got an Hadoop. It's only running on 3 nodes. It's equivalent to 65 gig. And I can start some instances into this Hadoop cluster. And what should happen when I do that is that the amount of node should increase, and the space available should also increase. Also, it could all crash and burn into a heap of smoke, but you know, we're going to give it a go and we'll see how it goes. So when we do what we've got to do that is that we've got my good old friend, so I could do it through the web interface, obviously, but I just need to find my terminal and then I'm safe. There we go. Where is my mouse? No, wrong way. That one. So can you all see it? Okay, so that's my cloud controller. You can describe the images. Okay, so it's nice and clear. Screen is small and the font is big, so I'm sorry, that's why it's not that clear. But there I've defined an image which is called Hadoop data node. All right, what is going to start? I'm going to pass it a script. This script basically is really quite complex. It's just pointing out to the Puppet server, because my Puppet server is also running on, no, not slash, it's just extra. Okay, so my Puppet server is also running in my cloud, so I need to the instance which are starting, I need to provide them with the IP address of the Puppet server, and I just do that simply by adding it to my good old etc host file, where it will know and grab how to go and get it. Okay? So my Puppet server, I don't want to, when I switch off the instances, I don't want to lose the data. So what I did is that I can use EBS for storing data as a kind of SAN, but I can also boot out of EBS. So with Eucalyptus 3, we've got the boot from EBS, which more or less provide you the same as what a virtualization platform does. Okay? So you get an instances, and when you switch it off, nothing goes away. And when you restart it, everything's still there. That's the theory, really. But, you know, it works. So I'm going to start some few more instances. So I wanted a name on the EMI, which is this one. So I'm going to say Yuka, run instances, -k admin. So that's my security group that I want to, that's the key that I want to use in order to start this admin. The type I want to have is going to be M1 extra large. It's Hadoop, you need a lot of power. -f for the files that I want to provide it with. Allez, let's be crazy. I'm going to start 2 of them at the same time, so we should get 5 at the end. And here we go. So that's done. I can log onto my Puppet server. We can have a look at the log file, and telling a log file are pretty easy in the presentation to tell a log file. So what should happen is that they're going to start, and when they're going to start, they should arrive to my Puppet server, say, hi Puppet, what's up for me? They should get the Hadoop recipe. So Hadoop Eucademo is there, so that's the log file from the other one. And they also should get my NTP configuration, just to make sure that they're on time. So now that's the scary part, that's why you wait and you think, my God, it's broken, it takes that long. So we're going to go and have a quick look just to be on the safe side. Here we go. So Yuka describe instances. Ooh, no, instances. And the first one to see 2 extra large in pending stage are the winning people. I don't see anything. But I'm just going to blame it on the terminal being small and trust my solution. Some stuff have happened in my log file, so I'm probably kind of all right. So now we're going to go back onto the web interface, into our desktop station. Where is it? We refresh, we cross finger, and if it's moved from 3 nodes to 5 nodes, and we've got more storage, we will call it success. Hey, it's done it. So, not that I was not going it, you know, I was sure it was going to work. I mean, I've done that many times. We've got 3, we've got 5, and the storage moved from 65 to 100 gig. So, we're good, okay? So there, I've just increased my HDFS cluster by 2 extra nodes, and I can now run some Hadoop job on it and see how it works. Another, I've got still a bit of time here before question. Okay. Another stuff that I wanted to show is the idea of elastic IP. So the elastic IP, no, that's not, that's why we were there before. The elastic IP, it could be convenient for the purpose of upgrading something, okay? And the presentation earlier was really good. He was speaking about how to do change in production and do it live and have the button to reverse it back. And I've cited through a presentation of the guy at Netflix. And Netflix is this streaming media company which is in the US. They've just arrived in the UK. I don't believe they're yet in Germany. We don't have them in France as well. But anyway, they're really quite cool. They're the biggest Amazon user. Okay? 10,000 instances at any single point. And they don't have all developers do the change onto production live. And, you know, it sounded, I mean, I'm coming from this traditional, I used to be a sysadmin, so I used to have prod and test and dev. And, you know, I like the idea of changing stuff, but not that quickly and not the developers onto production. And the idea, the guys are doing it, and they're really pleased with it. And why do they do it? Because they've got elastic IP. So they extend a new cluster, they do the change onto their production, they move the elastic IP to this new cluster, and if it doesn't work, they don't switch off the old one, obviously, but if it doesn't work, they just revert back to the old cluster. And that's what I wanted to show there. So I've got a web server which is running some really important data, as you can see. I've done it when he was presenting earlier, that's why, you know, I could have done something nicer, but it's changing often, changing quickly, that's what, yeah, I'm going to be fooling it there. So I've got a website showing something really important, and, you know, business critical, obviously. And I'm just going to play with my elastic IP. If I find my terminal again, there we go, my terminal. And I'm in the right place. So I'm going to change my elastic IP. So I've got 2 instances running web server. I've upgraded one of my web server with some new content. And what I'm thinking right now is, which one is it? I think that these 2 there. Is it, yeah? Well, we're going to say it's these 2. Sorry, what? No, in production I've got a larger screen, 13-inch screen, I can see it all at once. There I've got multiple lines for the same thing, doesn't make my life easy. So we're going to just do ucar associate addresses -i, and you all cross fingers. Wait, actually it should be easy. Bang, bang. Do I got a reserve in front on top? Yes, that's the puppy. So, -i, this one, and I'm just going to change the IP, 109. And now if I find the web stuff again, and I hit refresh, hey, here we go. Just the stuff had worked, just the refresh button which wasn't working. So my new data have arrived, and yeah, that's probably the end of my presentation for today. So yeah, that's the elastic IP. I had some content, I had a web server, I've moved to this new web server, and I get the new content. And if, for example, it was not to work, I can just revert it back. I'm not going to look again through my terminal to see which instance it is, so I'm not going to do it, but it just works. I can do that as much as I want until I finalize and I can really go live with this production data. Okay? Do you have any question? Yes, please?
When you talk about images, do you talk about a set of configurations? I'm asking, when you create a new instance in the background,
yeah,
what is happening in the background? Do you set up a new VM from scratch?
No, it's an image. It's an image. It's a template, if you want. It's whatever you want to call it. So there is some data on it. Okay. So don't put a host name in fix. Call it something else, like localhost, local domain. It's going to be DHCP. So I'm going to get my host name out of my DHCP server. Okay. And don't put any other configuration which are important. Use Puppet or Chef to do the rest. Yes. And you should be done. Then there is multiple ideas about how to manage images. One of them is when I want to run into production and I want to be really fast and start in images really fast and get workload spread across all of these images at once, I'm going to bundle as much data, as much application as I can into my images. And I will just use Puppet to do the last changes of the configuration. Okay? Another theory is to start an image which is blank and use Puppet or Chef to just push everything in it.
So how do you deal with the update levels?
The update, if I update an image, for example, I've got this image now working with my new website, and if we say that this is really scalable, I've got a command which I can run on this running image, which is going to bundle these new images. So if I want to update it, I can now update it, yum update, for example, it's CentOS, and rebundle it, and I get the new images out of this image.
Okay, so it's the, yeah.
What's the...
No, mask, because if I have to, for any reason, to maintain or to roll out an RHEL 6.1
yeah,
instead of a RHEL 6.2 because there are some, I don't know.
Multiple changes, yeah?
Yeah. But the customer wants to have a 6.1, then you have to have two main images.
You've got two images, yeah. You've got two images with two different times. You've got a 6.1 and a 6.2. Yeah. But it's always the same idea. You know, when you do patch management the old way, where you've got an OS and you patch it to 6.1, you're going to have your prod which is running 6.1. your test and dev is moving to 6.2.
Okay.
When 6.2 is being defined as stable in your environment, you're going to upgrade your prod to 6.2, and probably by this point you will have 6.3, which will be out, or 6.4, or 6.5, or whatever it is, yeah? So you don't patch the same way as you do. You don't do the patching like I've been patching for the last 8 years. You patch images, and you move these images up through there. But at the end, the result is exactly the same.
And why you do not use the, for example, maybe the satellite server to freshly install a 6.1, 6.2, or 6.0, and then
bundle
the
it?
Puppet and the configuration?
But you can. I mean, if you want, you can have a simple images which start and have do a YUM full install through the satellite. Okay, register in the satellite and do everything through there. Downside, when I'm going to switch off the images, the image is going to be lost in the satellite. The satellite is going to say, "Oh, I've lost someone." Okay. Secondly, the time that you're going to use in order to install everything from scratch is going to be really long. Also, it means really long. Okay. It's quick, but it's going to be longer.
Yeah.
All right. And secondly, what's happening if my satellite is not available at the time?
You told that you can use, for example, KVM and VMware and maybe Hyper-V.
In the future, Hyper-V, if you really pervert, yeah.
But there you have to have 3.
Sorry.
If you want to have this flexibility and switch over to all these platforms.
Yeah. No, you've got one single one single images, and we're going to be able to do it all on once. Okay. So we've got some trickeries that we can do at the FSTab level, because that's really where you're going to have the issue. SDA, XVDA, VDA.
It's not a template like in VMware template. It's an image, an Eucalyptus image. And it's then
honestly, I create my image using yum command. Okay, so there is no, it's not really much of a trickery. It's I do a yum install minus install root equals this folder, and I'm done. Okay, so no, it's okay. Yeah, screensaver. Sorry.
Okay, thank you.
Any other question? Yes, sure. At the back.
What's the minimum amount of machines I need to try this out?
Oh, sorry, 2.
2?
2. I forgot to mention it. So, you've got 4 components, I was saying, the Walrus server, the cloud controller, blah, 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 blah. They're all installed on one. You can all install all of these components on one server, and then you will need an hypervisor.
Okay.
Okay, so 2. And if you want to be really cheeky, you can install all of the components into one VM. But then that's really naughty, and you shouldn't do it.
Any other questions? Well,
No.
so, Olivier, thank you very much.
Thank you, guys. Have a nice day.